Hello and welcome to an Etoys Minute, or two, with Mr. Steve. When we last left Pops, he was dancing on Mars. But now, we're going to take him a little further, into outer space, and the billions and billions of possibilities, with code. Here's the code we used to create the green screen. The first thing you'll notice is recolor, the name of the method. Next, we declare some temporary variables, old form, old, new, and average. These variables exist and only within the recolor method, nowhere else. Next, we take the variable old form and we point it to our original picture of Pablo, the sketch. We get the graphic or the costume of the sketch and a pointer to that in his green screen form. We then create a new form here, and the extent of that form, which is basically the length and width, is the old form's extent, its length and width, and a depth of 32, which is the number of bits used to represent each pixel in the image. Here, we are going from 0 to the old form's height minus 1. And we're doing that for y. So basically, we're setting y from 0 all the way to its height minus 1. Another way of thinking of that is for each y in the image. So basically for each y in that image, that can be written and said many different ways. Here's how you would write it in Smalltalk. Here's how you could write it in Python. And here's how you would write it in JavaScript. So basically, it's an iteration. We're going for each y in the sketch. Now what we're going to do for each y is everything after this little pipe. We're going to do this. For each y, we're going to do this once. Now the first thing we're going to do is we're going to go from 0 to the old form's width minus 1. So basically what we're doing is for each pixel in the image. Here's how we are saying for each pixel in Smalltalk or Squeak. Here's how we would say, another way to say this is for each y, and then for each y I'm going to go for each x. Once I'm done with all the x, I go to the next y, and then I go through each x again. And here's how you could say it in JavaScript. Now another way to think of this is iterations. Picture this as a bunch of pixels in the image. Pick random colors. And what I'm doing is I am going to increase the cursor and point to the next one, and then I'm going to get the color of that cursor here, which I've stored in this block. So I'm just iterating through and getting the color. For each pixel, I'm going through and grabbing the colors. This is another way to imagine iteration and the for each pixel. It's good to imagine and visualize and think about things in many different ways, whether it's in specific syntax and semantics for a particular language, or even visually or kinesthetically, which means like something you do physically. Now here's another way to think about iteration, and basically what I'm going to do is go through each picture in this little holder. So I increase my cursor and I set it look like this. So basically by iterating through this holder, or this collection of images, I can create an animation. Well, that's nice. A biting shark is interesting, but what else can we do if we put two iterations together in a couple other scripts? We can do something like this. So again, we're using iteration in multiple ways. That's another powerful concept. If you learn something, find multiple ways to use it. Alright, so we're going through each pixel, and what are we going to do in each pixel? Well, first thing we're going to do is we're going to take old and get the color at XY. So basically I'm going to start at 0, 0, I'm going to get the color, I'm going to move across each X, I'm getting the color each time, I'm going to come up and basically iterate through here, and I'm getting each color. Next, I'm going to get the average of the red, the green, and the blue from the old color and divide it by, I'm going to add those together and divide by 3, which gives me the average. And as you can see, if you sort of look at the red, the average is up here. It tends to average somewhere, let's see, 40s, 37, 30. If I go to this light blue, the average is around 68, 70. If I go to this red over here, it's more in the 20, maybe 30 range. So it's interesting. The same color tends to be in the same, around the same average, plus or minus. And that's, in effect, why the next portion of this works. Because what we're going to do is we're going to compare the old green. Remember, we had a green screen. With the average we got from the red, green, and blue times 1.3. I just picked that. You have to play around to find out what the right multiplier is to work for the particular picture, green screen, and lighting you have. Now, if old green is greater than the average times 1.3, we are going to do this section of code. Now the key thing here is this alpha equals 0. Basically that's setting it transparent or invisible. You will not see that pixel. If the average is not greater than 1, or if old green is not greater than the average times 1.3, we'll do the if false statement, which is basically taking the old color and using old alpha so we can actually see the image. So then we're going to take that in my new form. Remember we created the new form up here and created this extent, which was this picture here. And we're going to take the color at XY, we're looping through each pixel, and put the new color we got, either the transparent or the old one. So here we might go here, and I pick the color from here, and I would go like that. And then I'll move to the next pixel. I would pick the color and go get the color there. Now, of course, because if I got my algorithm right, I wouldn't show the actual color. In other words, I wouldn't go through this if false. I would set my alpha to 0, and it would be, in effect, invisible. So here is the whole thing. For each pixel, we go through, we get the old color. We get the average of the old color. We compare the green value of the original to the average. In certain cases, we'll set it to completely transparent. We don't see it. In other cases, we want to copy the color exactly as is and put the pixel into our new form each time. Then what we will do is we'll take the graphic of the new image and we're going to use that new form, right? We were basically drawing a new picture, or a new form in this case, pixel by pixel, and when we do that set, we should get something like this, where the green screen image is gone. So here, we have taken code where no man has gone before, and your mission, should you decide to accept it, I know I'm missing TV shows, is to take your code where no kid has gone before and create new and wonderful things. This has been an Etoys Minute, or two, with Mr. Steve and Pops flying off to worlds unknown.